Yeah. How was it? Anybody take it? Heard it hurt or rough? Some parts of it anyway. Did anybody take the SAT? Yeah,
It sucks. Sitting there for 5 hours is literal hell. Like, your back hurts after the test.
Yeah, I know. Glad that's over with. And now it's final stretch time, which is kind of nice to be at that point where we're really just looking at like seniors who got like 2 more weeks. Everybody else who got like what, 4? And then final, right? 4.5 maybe. And we'll talk more about what that's going to look like as we get a little bit closer to it. But we'll have a regular final. We'll kind of take that during our regular scheduled time. Okay. So that last class work on all this stuff that was due last night. So if you did not get that in because you forgot it existed, class 4.6, make sure you do that. Okay. Because all this stuff is done. Compound interest and all that stuff, we are good to go. Now, we're still going to stick with the exponential stuff for sure, but like these formulas and things are they're going to disappear a little bit. We'll come back to this number for sure, that number E a little bit. Once we get a little bit further kind of down the road, but we are going to switch gears a little bit. So as we kind of wrap things up, it might be that we just kind of ride this out for the next 3 weeks or so, and then kind of start reviewing for whatever the final is going to be. I don't know that we'll have much time to do much else. So we'll see how this first week goes. Just kind of play it by ear. So, but let's do it. They got something to write with, something to write on. I'm gonna erase some stuff, and we're gonna move on to the last or the next and final section, I guess, if you could call it here in this exponential one, which is gonna take us a little while, sure. So I think today we'll just kind of start off relatively easy and see what we can do kind of in our head with a little help with the calculator. You may want a calculator, and you can of course just use your phone to do that. Because the exponents numbers get really big really quickly, and sometimes it's hard to have some of these things memorized. So let's do it. Let's do it. You find a decent panel. New ideas coming though. Okay, we looked at exponential growth and decay. We looked at percent growth and decay, compound interest, continuous compound interest, all that kind of stuff. All based on looking at the function. Okay. Now we're just going to solve exponential equations. Okay. Solving exponential equation. The last thing that we do not know how to do. Okay, so I would start someplace relatively brand new, someplace kind of clean, because the ideas are definitely, a little bit different. Now we're actually trying to solve for something. And the way that I think that this would work out best is to start easy with ones that maybe you don't even need a calculator to do. Building up to ones that, the numbers get kind of big, so I'll use a calculator to help kind of confirm what I think might be the right answer. And we can get really, really, really nice answers, for sure. And I'm building to eventually, okay, like how do I solve an equation that I really, I can't, just don't know exactly what that number is. And I think the best way to do this is just kind of jump into some easy ones rather than going into the tough ones right away. So what you're going to see me probably do here today is just kind of work through one example after another, kind of seeing what you're comfortable with, seeing what you can get either in your heads or with a calculator, and then kind of going from there. So call this one number 1. We're just going to start solving them right away, but maybe with the setup, you can just look at it and know what the answer is. For example, 3 to the power of x. So there's a thing that we don't know. Trying to figure out what the exponent's going to be. Whenever we're solving exponential equations, it's the exponent that's going to be the thing we don't know about. 3 to the x equals 9. And maybe you can just look at that and say, I know what number has to go in the exponent to make this equation true. I can just look at this and say, I know what x is going to be. Can anybody do that? Can you look at 3 to the x? What we got down? 2, right? 3 squared is 9. I'm done. But if you didn't know that or you weren't sure, you could always jump into the calculator and say, okay, let me try 3 to like the first, 3 to the second, 3 to the third, and see if I get exactly that number. Because if I can either figure it out or like kind of guess and check my way to it, of course, guess and check is not very mathematically sound, but it is something that we do sometimes just to make things work without like kind of doing algebra, I guess. You can get there. 2 to the x equals 16. What do you mean you can't see the whole board? Is it blurred? You only need this side right now. Let me know. Can anybody look at that and figure out what that exponent is supposed to be to make that true? And it's not 8, right? It's not 2 times 8 is 16. It's 2 times itself a bunch of times. We're trying to figure out how many times we have to do that. 4, right? 2, 4, 8, 16, right? 2 to the 4th power is 16. And right away, you can see that, okay, cool, like I could do a 3 squared equals 9 kind of one, but I did not look at 2 to the x equals 16 and automatically come up with it, right? Those numbers can be hard to think about right away. And it's not a really, really big answer, and the numbers in the problem weren't very big either, but it could be hard to think that through. And so I want to come up with a way to help you do that without having to like think, okay, 2, 4, 8, 16. I want to see if we can figure out a way to do that. I don't know, like 2 to the x equals 8. And you just look at that and know what the answer is, or at least figure it out in your head. If you can do that, great. I don't need to see the things that I'm going to teach you, like how to actually, like, how do I get the x out of the exponent kind of mindset. If you can come up with the answer, I'm cool. If you can look at this and say, okay, I'm just going to multiply 2 by itself until I get to 8 and count how many times that is, then I got the answer. So there it is, right? If you can say, oh, 2 times itself, 3 times is 8, I'm good. But that's up to you in your head. Is that something that you can do? Or is that something you even want to do? Right? As these numbers get a lot bigger, it can be hard to do that in your head. Even numbers that aren't really all that big. You know, if I start raising like 4 to a power, you know, and like, yeah, 4 to some power is supposed to be 256. Like, that's kind of the question I'm trying to figure out. Multiplying 4 by itself, like you get to 4 times 4, okay, 16, but then times 4 again, God, it's like more work in my head than almost it's work, right? Because, all right, 16 times 4, 64, right? And then can I multiply it again? Like, do I get exactly there? 4 times, so 4 squared is 16. So the third is 64. So the 4. 4 to the power of 4. And we can get to the exact right answer, but I mean, my base here is only 4, and that was really hard to do in my head. And I really don't want to be sitting there in a calculator trying 4 squared, 4 to the third, 4 to the fourth, 4 to the fifth, and just hoping to get left. Because I'll tell you what, there's a heck of a lot of answers that don't end up really nicely, right? 4 to the x equals 255, 254, 253, 252, 251. Like there's so many answers I could have put right here, so many numbers right here that make this super gross right away, right? Now, maybe it's 3.5 or 3.1, but maybe it's just not nice. Right? Maybe there is no perfect, nice, beautiful exponent that's going to get me to that spot right away. And so that's kind of what I want to, I don't know if we'll do it today, but that's kind of what I want to build to soon. But I want to start with questions like these that do have really, really, really nice answers. But you can see, hopefully, I'm trying to drive this home, it's not easy to do in your head. It's not. Okay, unless you have a very intuitive brain for exponents, which I don't think many of us do. I know I don't really, honestly. It can be hard to do. So I want to come up with some strategies. I want to give you a way that even if the answer is nice or it's not nice, we have a button in the calculator that we can press and it's going to give us the answer one way. Okay. But I want to deal with slightly trickier ones like these that have really nice answers so that we can think about what we'll need to do when the time comes when this stuff gets a little bit tough. But before I do that, any questions 1 through 4 here? Okay, cool. So those are about as simple as I can make them. Whole number bases, whole number answers, whole number exponent results, right? And even that was hard, right? You saw me, I don't know if you saw it, I was like straight, I was like, all right, what is 2? I want to do 4 to the 4th. I had to think about it. I was like, I don't really, off the top of my head, I don't know what that is. But the thing about every single one of those problems is that the base and the exponent were the only things on one side. Not everything else had kind of moved itself over. Like, what if the question didn't have the base and the exponent by itself on one side? You can try thinking this through and like guessing and checking your way to an answer that's going to work, but the more adding, subtracting, multiplying, and dividing, messing with these numbers that we do, the harder that's going to be. So I think a good strategy would be to try to isolate the 2 to the x, get this on one side by itself, moving everything else over, and then stopping and thinking about what number. And this is just solving equations, right? Addition, subtraction first, we'll do the opposite. Multiplication first, second, we'll do the opposite, right? We can do all of those same kind of algebraic tricks, like working, from the bottom of order of operations backwards, trying to undo what's happening. But we can't get x by itself because there's no, not yet, there's no way to get the x out of the exponent. Not yet. So the thing that we're going to try to isolate is not the x, but the 2 to the x. We can get that by itself, then we can just have a 2 to the x mindset and see where it takes. So what do you think we could do to both sides here to get it alone? Subtract 1 on both sides. We can do the exact same solving equations kind of setup that we've always done. I think that's going to be really, really helpful. Now look at what you've got. 2 to the x is 4. 2 to some power is 4. Can you figure out what that is just by looking at it? 2 squared. So there are problems that are simple enough that we can go after them kind of straightforward, like we always have with equations, and then just think about the answer. That's not always easy. Three times 5 to the x minus 6 is equal to 69. Again, you want to try to put numbers up in that exponent and see what works? Good luck. It's especially when we don't get really nice answers, it's going to be all but impossible. Instead, let's see if we can get this by itself and then think it through. Maybe that'll be enough. Let's simplify this as much as we can by kind of moving everything else away, getting the 5 to the x alone, seeing what we get. So what could we do first? Just start simplifying that left side.
5, 6, both sides.
Beautiful. Plus 6. This one's gone. 3 times 5 to the x equals 75. Divide by 3. Sounds good. Now, if this was gross, I would just leave it as the best fraction I could. But 75 divided by 3 is exactly 25. And can you just look at this? 5 to some power is 25. And come up with the right answer? Yeah, 5 squared is 25. And hopefully you knowing your perfect squares will come into play in making this a little bit easier. Cool? So, same lines. Now, here's the part that gets tricky. All right? Okay, cool. Like, 2 squared is 4. 2 to the third is 8. Okay, so what's 2 to the what is 7. 2 squared is 4, so it can't be 2. 2 to the third is 8, okay, so it can't be 3. All right, so somewhere in between 2 and 3, I guess, right? But that doesn't sound like good math. Somewhere between 2 and 3. No, we need to be a little bit more exact than that. Go ahead, take out your calculators. See if you can put a number up in that exponent that gets you to be exactly 7. Like, try it. Like, all right, so 2, like, obviously 2 squared is not enough. 2 to the third is too much. So, 2.5, try it. Try it out. Try it out. See if you did like 2 to the power of 2.5. See what that gives. If that's not enough, or if that's too much, then adjust one way or the other. See if you can get an exponent that gives you exactly 7. Nothing exactly. How close did you get though?
2, 4, 2 to the power of 2.81.
2.81. What'd that get you?
7.012.
Ooh, that's pretty close. Only off by like 0.01. That's pretty good. But you never really get there. And so 2.81 was a little bit too much, but 2.8 was not enough. So now we go into like 2.805 or 807. Like now we go 3 decimal places and 4 and 5. And what you'll see, you'll never get there. The answer to this is a decimal that goes on forever, right? Just kind of like x squared equals 5. There really is no perfect right number that I can put as a decimal to be exactly right. And so what we need is a different way of writing this equation that's going to get x by itself. Kind of like, when we did x squared equals 5, like we rewrote the same equation, like this and this are the same, just written differently, that gets the x by itself, right? And I know that like this is obviously a better version because it does what I want, it gets x alone. It's just that this number, right, whatever this was, 2.3, blah, 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 It just goes on forever. So the best way to write the square root of 5 was the square root of 5. And so that's what I want to do here. Okay, I want to rewrite this equation so the x is by itself. But the problem that we have with trying to do that, we don't have a way, like you haven't learned how to do that part yet. There's never really been a way so far in your algebra careers that has gotten you to the point where you could take an exponent out of the exponent and like make it the whole left side. Like I can undo exponents, right? X squared equals 5. I can square root both sides. I have like an algebraic move that I can make. There's a step of work that I could do to this, right? I could change colors and do something. Same thing here. We can do something. But the something is not let me add or subtract or multiply or divide or square roots. The only thing that we can do is rewrite that equation differently. Okay? This is going to be brand new. I'm going to teach you something you've never seen before. Just like addition, subtraction are inverses, multiplication, division are inverses, square and square roots are inverses. There is an inverse to exponential function. Right? The first thing that we have to do, of course, is to isolate the base, the exponent, on one side. So I need b to the power of e, as you know, base is b. I have to isolate them. Now that is like we did with like 5 and 6. Okay, I'll subtract 1 or I'll add 6, divide by 3, whatever I need to do algebraically. So I'll say that isolate b to b algebraically. Kind of a straightforward setup. We know how to do that with subtraction, multiplication, division, things like that. And what that does is it will give us an equation that looks like this. B to the e equals some number. Right? Can't have x's on both sides, and we're out of luck, right? So what's going to be over here on the right is just going to be any number, anything, right? 7 or 25 or 4 or whatever it is, some number. I'm just going to put n for number. Okay. Now that e up there is not like the e number that we came up with. That's just any exponent. That's of course our. Now what I'm going to do is I'm going to show you how to rewrite this equation differently. Okay. Now what I'm going to show you, like, these are one and the same. You can go in either direction. You can change from exponential form into this one or back. Now, this is really, really new. When you think about like math, like how much has math changed in the last 5,000 years? Not very much, right? At least not at this level, right? The big changes that happen mathematically are way, way, way above where I've studied, right? Way above any education that I've ever done. But the stuff down here doesn't change very much. But this is actually relatively new. The name of it is going to sound kind of weird. It comes from Latin, and there's a whole big explanation for like how the words all come together. So I'll spare you that. But we have to change from exponential form into a different one. Okay. The inverse of exponential functions. This has a different name than you've ever heard. Looks like this. Logarithm. The inverse of an exponential function is a logarithm. And it is a brand new thing for everybody in this room. Okay. Now, exponential form, right? I'm just going to call this logarithmic form. But what you're going to see is we're going to be dealing with logarithms. And all it does is it gets the exponent out of the exponent and by itself. Okay, so you're going to see way over here, it's just going to be equal to the exponent. All by itself. Yeah. And that's its sole purpose. Its sole job is to be the opposite of an exponent. And give me the answer for an exponent. Okay? Now this left-hand side. Give myself a little bit more space. Okay? There's obviously, like, this whole equation has three parts to it, right? The base, the exponent, and the answer. The n, right? Now, this equation I'm going to write it in only has the exponent by itself here, so I still need the base and the n, like, on the left side. I have to put them in a certain spot, okay? And here's what logarithms look like. They have both in them. Like a logarithm, I know it's weird, I know it's new, it's like a whole new function whose job is to take a base and the answer, the n part, and tell you what exponent would work. Like that's its whole job, is to say, okay, give me a base and give me the answer. And I'll tell you the exponent you should put up there to make it work. Cool? So what you're going to see is I'm going to write, like, b and n are going to be over here. But I'm going to write the word logarithm as part. So you know that I'm dealing with the opposite. But we're lazy. We're mathematicians. So I'm just going to put the first three letters in. Okay? Log. No, it kind of looks like 10 genus. Log. And I'm going to call them logs a lot, rather than just logarithms. You're going to say logs. Okay, here's what it looks like. This base is pretty low, right? It's underneath the exponent. So when I write a logarithm and I want to tell you what base it came from, I'm actually going to drop myself like down a little bit, like not even with the word and the equal sign and the e. I'm actually going to come down to what's called this subscript location and put the base down there. And I'm going to say this out loud as log base b. So you know that it came from an exponential equation that had a base of whatever b is, like in this case. But I need the n as well. And so here's where the whole function part of this comes in. I actually kind of write it like f of x. Like here's my function. I'm going to put something in here. I'm going to put the n in there. Okay, log base b, and then in my mind, like f of x, I'm going to say of n. Like, here's the logarithm, it's going to be the opposite. Here's the base, so log base b of n. Like, here's my answer that I want to get to. Please, please, please tell me what that's supposed to be. And that's what base is. And so this right here, that n, called an argument. That's the fancy name for it. Not argument like you get into a difference with somebody and you argue about it. It's more like a computer science. I don't know if anybody does computer science and arguments. Now that's brand new stuff, and I want to give you an easier way to remember it. Okay? Usually I'll even write it like the other way, I'll put the log on top of the other one, okay? Check this out. Hopefully this helps. Log bene, like say it out loud if you're like pronouncing the word. Log bene is ben. Log bene, base, argument, exponent, in that order, base, argument, exponent, is ben. Let's just say it yourself. Log bene is ben. They are the same thing. These two mean the exact same thing. Just like x squared equals 5 means the same thing as x equals squared. Just like 2 to the x equals 4 is the same thing as x equals 2. These are the same equations, solving for the same thing. One just does a really good job of isolating what I'm trying to solve. This doesn't do a good job. This one does. I can do that algebraically. This does not do a good job. This one does. And so what I want you to start doing before you ever actually write x equals, to back up a second, take a look and say, okay, what's my base? What's my exponent? What's my argument? I'm going to call it that from here on out. Okay, anytime I talk about the argument, I'm talking about the answer to an exponential equation, the thing inside a logarithm. And if I can figure out what B, E, and N are, I'll just write them in the log Binet order. Let my calculator do this. So, what's your base in 2x, 2 to the x equals 7? What's your exponent? What's your argument? And by having that little bit of like pre-work, kind of like we've always done with like A, B, and C, like that has really helped us with factor, it helped us with quadratic formula, it helps us with negative B over 2A, all that quadratic stuff. Now with exponential stuff, if I can figure out what B, E, and N are, or when we start solving logarithms with B, N, and E are, because that's the orders that come in, now we just make the switch, okay, from Ben into log Binet. Do you remember that? Log Binet is Ben. Right? And it helps a lot. Because if I can put the base, the argument, and the exponent in the right spot, right? Base of 2. So it's down here, right? Log base 2. I go down into the basement a little bit. Take the stairs down. Of n, okay, of 7 equals x. Look what's by itself. X. And that's all I want. That's all I ever want. Solving exponential equations. Get the x out of the exponent. We created an entire function whose sole purpose is just that. Now, what the hell is log base 2 of 7? Let's find out. Open up your calculators. Can anybody find anything in their calculator that resembles a logarithm? Right next to the 7, there's a log button. But look what happens if you press log. Does it give you a chance to type in the 2, or does it open up the parentheses right away? Yeah, parentheses right away. Like it knows it's a function. That log button is a specific one. It's log base 10. When the problem that you were starting with was in base 10, where it was 10 to the x equals whatever. Okay. Why is base 10 so important? Why is it given its own button? We have 10 fingers, we have 10 toes. The whole decimal system is based on 10. The entire metric system is all in base 10. Okay, but not everything in the world is base 10. But because it was so important, they put it right on the front. If we want to type in a log that happens anywhere else, log base 2, log base 3, log base 5, log base pi, log base a million, whatever, you have to dig a little bit deep. Okay, let's hope it's on this app. I hope it is. Okay, what class are we in right now? 6th period. More specifically, Algebra 2, but less specifically, what kind of class is this? This is math class. Find the math button. The most popular one, when you are going to find something, press the math button. Okay? Scroll down to the bottom and see if you can find something that says log base. In your calculator, okay, press the math button and find log base. Find it? Doesn't it give you a spot for the base and the argument? Nice. Okay, now I got to type it in. Log base 2, so press the 2. And it should just put the 2 right in that little bottom spot. What do you think we need to press to get into the argument? Right arrow, cool. So we'll right arrow ourselves in. We'll press the 7. What was your guess down? 2.81, right? Go ahead and press enter if it didn't show up. 2.80735. That's pretty good. Okay. But what do you think? Do you think that number stops right there? Goes on forever. So should we round it if we want to be exactly correct? Like, right, did we like write the decimal for the square root of 5? No, we left it exactly as is. So what do you think the best version of log base 2 of 7 is? But that would be rounding, and I don't want to be like I don't want to be close. I want to be perfect, right? This is like about like 2.37, blah blah blah. I don't want to round. I want to be exact. Just like we typed this in the calculator, got a nasty decimal, said no, I don't want that. I'm just going to use this. We type this in the calculator, get a nasty decimal. What do you think we should do? Stop right there. That is the best version of that answer. If you're looking for an exponent and it's just not a really nice number, done. It's a log. Okay. Now, if you have that saved right there, hopefully your screen looks exactly like mine. Log base 2 of 7. Maybe you pressed enter. Maybe you didn't. Just sitting there. Okay. Check this out. Here's where it came from, right? 2 to the x equals 7. Let's test it. Do this. Press the number 2. Raise it to a power. But here's the thing. I want my power to be exactly this. Not 2.81, not 2.807. I want it to be exactly this. I want it to be my exact answer that I just got. On your calculator, it actually stores a lot of information that we don't realize, including the last thing you just typed in. The way that it stores that last thing, look, so below the 3 is like the negative button, right? Not subtraction, but negative. Look like what the second negative says. It's like second negative, ANS for answer. Watch this. 2 to the power of, I'm just going to put answer. I'm going to do second negative, and it should say 2 to the ANS. Go ahead, press enter. Look what you get. Okay, that is the best answer by far. Now, the good news about how nasty and brand new this is that we have the button in the calculator that can help us do this, whether the answer is nice or not so nice. All right, now let's backtrack just for a minute and take a step that's probably worth taking in between right here. When you isolate base, exponent, argument, if I can figure out what those 3 are, even if I know the answer, or I think I know the answer, I can use a log to be sure. So let's try it. Back to this one, number 5 right here. We got to here, right? 2 to the x equals 4. And cool, all right, I know 2 squared is 4, so I can just use my head. But what if I don't? Right? And what if I just want to be careful and make sure I don't make a mistake? If I can rewrite it as a logarithm, I can plug it in a calculator and make sure I get it right. So what's the base here? 2, okay. What's the exponent? And what's the n? 4. What's that called again? The argument. Yeah, okay, cool. Now, write it not as ben, but as log the name. Write it instead as log base 2 of 4 plug it in. Right? B-E-N, base, exponent, the number or argument. So there they are. And what this function does, it just kind of shifts stuff around. It just puts things in a different order so that I can get the exponent all by itself. Now, what I should hopefully be able to do is type in my calculator log base 2 of 4, and it better spit out 2. So let's do it. Math. Scroll to the bottom until you see log base. It's got a blank spot for the 2, so I'll type the 2. Right arrow into the argument to get the 4. Press enter. And as these equations might have nice answers, but maybe they're not quite so obvious, right? 4 to the x was 256. I don't know what that is off the top of my head. Now I can use a log right away without having to guess. Cool? All right, let's do just a couple more just so you can kind of get used to it. And then we'll call it a day and we'll pick up logs and exponentials again. So I didn't finish my little calculator thing. So math, log base, and then it's log base b of n. Press enter. Okay. If it's a nice number, use it. Right? If you get an exact, perfect, like exact number, we just got 2. Awesome. I'm not going to leave it as log base 204. That's ridiculous. I'm just going to call it x equals 2. It's like I don't leave the square root of 9 as a square root of 9. No, that's just 3. I'll just take it, right? Okay. I guess I'll just say not nice. Use logs. Use your logarithms. Okay. Leave it as a log. No, we're talking about logs in math class. But that's the thing. And it works. Okay, let's do let's just do one more. Call this one number 8. Hey, give me a number. Keep it small. Keep things small. Brianna, give me a number. Smaller than 4, bigger than 1. Johnny, give me a number. Any number you want.
55.
That's okay. Sorry.
You said any number.
Terrible decision by me. Terrible choice. But I'm sticking to it. Sticking to it. Okay, equals 86. Do we have our base and our exponent isolated yet? Are they alone on the left side? Then let's make it happen. What do we need to do first to get this? Right, so sounds good. Minus 55 on both sides. Let's see if I did the math right in my head. 4 times 2 to the x equals 32. We have this by itself, yeah. See how I keep circling that? It'd be a good idea, right? Circle just the base and the exponent so you know what you have to get by itself. What should we do to get it by itself? 5 by 4, sounds good. Does 4 go nicely into 32? Yeah, 8 times. Now, maybe you can look at that and know what the answer is. Maybe. But if you don't, or if you just want to be safe, now that the base is isolated algebraically, now we make the switch. Now we make the switch, okay? So all I really need to do is say, okay, what's the base, what's the exponent, what's my argument, and see what I get. Because it's in the order of Ben, right? Log bene is Ben. They mean the same thing. That's why I keep saying is, because they're one and the same. What's the base? What's the exponent? What's the n? Again, what is n? What are we going to say? The argument. Okay. Now, so I went from Ben, so that's my original setup. Now I'm going to go to log bene. I'm going to make the switch like that. So this is kind of like, in my mind, this is what I'm thinking. I'm going to go from exponential form, because I can't solve that because I don't know how to get the x out, to log form because that's it. So like that's all it does. Its sole purpose was created. I feel like it was, if anything in math that you've ever learned in this class has been created, it's the creation of logarithms to do one thing and one thing only, solve for x. So the base is 2. The argument is 8. So you see the order switches, right? 2x8, now it's 2/8, and it's equal. Again, we're just solving equations. Once I get to x equals, I know my job is done. I just want to write it as nicely as I can. So I check. Jump in my calculator, math. Right there it is in calculator, math, log base, type it in. Log base 2 of 8. What do you get? X equals 3. Yeah. Because 2 to the third is 8. But you could have done right away. Like if you see that, oh, I know that 2 to the third is 8. I'm just going to say x equals 3. But if you don't catch that, or you just don't know your powers well enough to be able to like really know that quickly, then don't. Take this path, right? Figure out, okay, what's my bend setup? Let me get those in the right spots. Let me set up log Binet, dropping in each of my pieces and letting the calculator do that. Good first step. I'm happy. Hold it right there. We'll come back and I'll just reteach it again. Yes.
Okay.
Yeah.
But how do I do it?
Well, so you can solve it algebraically to here, and then you use your brain. That's kind of the thing. Is like you have to see how much you can do algebraically just to get to here, and then you just have to know your powers well enough to be able to do it. And so then it's just log base 2 of 68. Huh? You should have during class.
You told me I first today. I didn't know if you
We should do it during class. Let's do it tomorrow during class. Tomorrow during
You're
class.
gonna make me wait 1 minute.
You want to take them out right now? So that's probably what I was doing. I would do as much algebra as I possibly could, and then just write it in log, not worrying about whether that log would be.
Not in class.
I don't think anybody's ever going to
And we just took him out.
know anything besides your perfect squares up to like
No,
15.
you don't want to.
One square, square, and then your perfect cube is like 1 cube, 2
I
cubes.
know. I almost left it in my car.
One that anybody would ever like reasonably expect to do without.
Hey, Rosie.
What's up?
Nothing much.
How was it?
How was what?
I don't know, everything.
Good.
How was the SAT?
Eh.